Alright guys, we're back. Talking about naming. So just to review just what we went over in the last video, we're talking about how to name ionic compounds. And so you can kind of go through a series of steps to decide which rules you need to use to name it. So the step one is to make sure that the compound you have is indeed ionic. And so what you look at to check that is you want to see if it's a bond between a metal and a non-metal, which means it's ionic, an ionic compound. Because instead, if it were a non-metal plus another non-metal, that would be a covalent compound, and we would use a different set of rules for naming that, and we'll talk about those rules later. But right now, we're just concerned with ionic compounds. So once you figured out that it's ionic, check, we've done step one. Then you move to step two. You want to check and see where the particular atoms come from on the periodic table. If they're from the main groups, those on the left, not these guys, and then you pick up back over here with these 6 groups on the right, if they're from over here, then you'll follow these type 1 rules, which is just what we went over, where you have a combination of your cation and anion. And so you leave the cation name the same, and then you add IDE to the ending of this anion after you've dropped whatever ending it originally had. So NaCl becomes sodium chloride, and CaS becomes calcium sulfide. Alright, so now we ask, well, what if the atoms that are in our compound aren't both from these main groups? What if one of them is from the transition metals? And that's where our numbering comes in. So what happens on the periodic table is that the elements in the main groups, they're pretty set on the ions they form. When these on the left form an ion, they're pretty set. Those in the first group form +1, form cations with a charge of +1. Those in the second group form cations with a charge of +2. Those over here in group 17, are also called 7A sometimes, form anions with a charge of -1. Those in group 16 form anions with a charge of -2, and so on. But as you can see in the transition metals, sometimes these guys, they have a choice. They can either be +2 or +3, or sometimes +1 or +3. It just kind of depends on what other atoms they're joining in with. So that's why we have to specify with a number which one they are. It's kind of like when parents have twins and they'll put them in different colored shirts so they can help tell them apart a little bit better. So it's almost like we're just needing to designate which one we're using. But I do want to caution you all because there are 3 particular compounds that you need to be aware of, that they're pretty set in stone too. Aluminum, zinc, and silver. These are the ones I've highlighted in yellow. And these always have a set charge, and they're ones you'll want to memorize. Because silver always has a charge of +1, zinc always has a charge of +2, and aluminum always has a charge of +3. So these won't need numbers because they're also set in stone. Alright, now let's get to some examples. So now let's look at this particular compound. So we ask ourselves, alright, 1, is it ionic? We say yes. It's a bond between a metal and a non-metal. Alright, so now we're checking to see if it's type 1 or type 2. And so we look at our periodic table, and oops, there's iron. And iron is a transition metal. So zoom in so y'all can see it. There it is, right on the top. So we know that we have to use the type 2 naming rules. So iron, because it's not one of those that's set in stone, we have to determine its charge based on what it's paired with. Now we know chlorine is one of those that's always set in stone. And so chlorine, when it's forming an ion, always forms an anion with a charge of -1. But if we look at this particular compound, we have 2 chlorines. So that means this part right here has a total charge of -2 because you have 2 of these guys. And so, in order to balance out that -2, what must this iron have? It must have a charge of +2. Alright, so you want the charges to cancel because we don't see any notation of charge here. Okay, so now that we know iron in this case is carrying a +2 charge, we'll get to the naming. So again, we take the cation, just write its name, iron, but this time we're going to follow it with a Roman numeral because iron is a transition metal and can form more than one cation. We have to note which one it is. So we're going to note that here it has a charge of +2, so we'll use the Roman numeral 2. Then same as before, we change the ending to "ide" on chlorine. So now we have iron 2 chloride. Okay, and now some of you all might be asking, well, do we need to have a prefix here and say dichloride because we have 2? And no, we'll find that prefixes will come in later in covalent compounds, because what happens here is that if it's iron 2, we know that we have to have 2 chlorides, because otherwise our charges wouldn't cancel out. So, there's that. Alright, now let's look at this one here and kind of approach it the same way. So step 1, we check to see if it's ionic, between a bond between a metal and a nonmetal, and it is. And now we look and see where our elements are coming from on the periodic table. And yep, there's iron again, right in the middle of the transition elements. So we know we're going to have to specify what cation it forms. So to do that, we want to use what we know for sure to determine what we don't know. So chlorine, we know, again, always makes an anion with a charge of -1. But here we have 3 of them. So that comes together for a total charge of -3 on this part of our compound. And so if this is -3, we know that iron must be +3 in order to cancel this out and cause our whole compound to be neutral. So again, just as before, we name our cation with its regular name, iron. Now we need to specify its charge because it's from the transition metals. So since it has a charge of +3, we use the Roman numeral 3. And then, just as before, change the ending of chlorine to chloride. It's a little hard to write. Put this down. There we go. So this compound is called iron 3 chloride. Alrighty, and one more example. So let's look again and go through our steps. Step 1, is it ionic? Yes, we have a bond between a metal, zinc, and a nonmetal, chlorine. Now we look and see where our elements are from on the periodic table. Okay, we're looking, and aha, there's zinc. It's part of the transition metals, but, kind of red flag alert, it's one of our special ones that even though it's in a transition metal zone, it has a set charge of 2+. And so because it has a set charge, we don't have to use a Roman numeral to tell it apart. So, zinc here we know is going to have a charge of 2+. And that matches this charge on the chlorines, because we have 2 chlorines, each with 1 negative charge, for a total charge of -2. And so those cancel out nicely to give us a neutral compound. And so in this case, we just proceed as we have before. Take the name of the cation, zinc. This time though, we don't need a number, because remember, zinc is set in stone, so we don't have to tell it apart from anything. Then, just as before, we have our chlorine, and we'll change the ending to "ide," chloride. And again, we don't have to put zinc dichloride, because here, if zinc has a positive 2 charge, then there have to be 2 chlorines to accompany it in order to make the whole compound neutral. So it's kind of just an understood that there are 2. Those prefixes will come into play later in naming covalent compounds. But here's kind of an overview of what we have so far. The video is having a little harder time focusing. There we go. Alright, so these are the rules for naming ionic compounds. I'm going to stop the video and then we'll talk about covalent compounds.